Thank you for introduction. So today we'll be talking about test pyramid. I think that this is a topic well known to everyone. And we'll talk about its genesis and how we use it in practice. But my talk I will start with a story about two different words, the word of monoliths and microservices, because it will help us to better understand how we can use pyramid in practice and why sometimes we do fail. So starting with monoliths. Monoliths are applications where the whole code responsible for front-end, for back-end, for connection with the database, everything is stored in one place. By one place, I mean not only that in one code repository, but it's also one project. And such projects are still very popular. And why is that? Because they're quite easy to start with. We just create a new project, add some front-end layer, some database connection, some basic business logic, and we just build it and it just runs. With the same simplicity, we can release it to production. We just need to build a package, put it on some server, and voila, it's alive. And if after a while we'll see that the performance is not so good, what we do? We just copy the package, put it on another server, place some load balancer in front of it, and we scaled such easy. But after a while, maybe, I don't know, a year or two, our application is getting bigger and bigger. Our code base is getting bigger and bigger. And I think you all heard the stories about projects that compiles like for 30 minutes. If you try to build it, your computer hangs for a while. So imagine that you need to join such a project. You need to read all the code. You need to know what is where. And it's not so easy task. And especially if you are given a new task, for instance, to change something in one place, some business logic, let's say. Luckily, one of your colleagues showed you where to look for it. Okay, so you did. You changed the code. You ran the unit test. Let's say all have passed. You even tested it locally. Well, worked like a charm. So that's great. So you decided to pass it to tester. So tester tested it on some test environment, let's say, do some small regression around it, but as I mentioned, small, because no one's got time for doing a full regression on such a big project, because we all know that this is neither cheap nor fast. So we got a green light to go to production. So we did it, we released it. And what happened? Of course, something else was broken in completely different area of the application. And why is that? Because such amount of code favors the creation of so-called spaghetti code. And it means that if we'll change something in one part of the application, something else might be broken. And also there's other disadvantage of monoliths, which is not very often mentioned, especially in a tester's world, is this commitment to the technology stack. Let's say our application was written in Java 1.6. We all know that this is a very old version. Right now we have Java 1.13. So if we would like to update it, what do you think? Will it be easy task to do? Well, of course not, because we need to do it at once for the whole project. Right? So we either need to stop the development of new features and just focus only on updating the Java version, or maybe we can create some other team that will handle only this. So that was very simplified introduction to monoliths. Let's now have a look at the microservices world. As you can see, the architecture is kind of different here, because first of all, we divided the front end from the back end. Sometimes front-end is even divided into so-called micro front-ends, and we have services. Services are created most of the cases per domain, so we can have a service which is responsible for user management, for instance, or for some invoices part, things like this. And in most of the cases, we got between them API gateway, which just transfers the calls from the front end to the back end. And that's it. So what advantages come with such an architecture? First of all, those services, by definition, should be small, right? So if they are small, the amount of code is not big. So we can avoid the spaghetti code, for instance. It's easier to maintain them, it's easier to actually change something. If we need to start with such a project, we don't need to, at first, know all the services. We can start just with only one. Another big advantage is that we can release them independently. So we don't need to release all services at once, and all the front and everything. We can just release only our one service. But in here, we need to think about backward compatibility. But about this, I will tell you a little more later. And in opposite to monoliths, in here, we do not need to have all services written in the same language. One of our services can be written in Java, another one in Python, why not? And also, if you need to update the version, for instance, of Java, it won't be such a big task again, right? Because the services should be small. But seems like we have found the cure for all the evil of monoliths. But remember that microservices can be really bad too. I mentioned previously spaghetti code. But in microservices, we can have something which is called ravioli code. I think yesterday, during one of the keynotes talk, there was a slide that showed the microservices in Twitter, I think. There are like hundreds of them. So something that was easy in the beginning, so you know the architecture, what connects it with what. After a while, if you have hundreds of services, it's not so easy again. So think about the testing, about all the integration tests. What can you test exactly, right? Because you've got one service, you want to change it, because you can release it independently. But how to assure that you will not break all other services, right? So the testing is really hard. And here comes pyramids to help us a little bit with that. But talking about pyramids, what do you think? At what year, for the first time, test pyramids were mentioned? Any guesses? Not 20? Any other guesses? Less. No. Almost, yeah. So, well, exactly 10 years ago, even, even the month is correct, right? So for the first time, Mark Kohns presented test pyramid approach in his book called Succeeding with Agile. But also I just, I saw, I think, on Martin Fowler blog that Mark Kohn for the first time discussed it together with Lisa Crispin and then presented on some Scrum gathering meeting in 2004. His idea was very simple. Because tests on UI level, as we all know, are very brittle, well, they're hard to maintain, they're very slow, just simply expensive, right? So that's why we should test less on UI level and move as more tests as possible to lower layers like unit tests or service tests. And it just seems right, right? It's hard not to agree with Mark. But Mark was not the only one. Jason Huggins, one of the creators of Selenium, independently came with the same idea in 2006. He presented it on some conference, PyCon conference, but he compared the test pyramid to the food pyramid. And as for good software health, you need to have all of them, all the layers, right? So we need to test, we need to have a properly balanced diet of tests, of course. So we got unit tests again, lots of them. Then we got, like on previous slide, we saw service as a second part. In here we got functional tests. And here he didn't mention exactly where we will test them. And just a little UI test probably written with Selenium. So we all agree with those both concepts, so we try to implement it. So let's have a look how we're good with this. So first, let's have a look at the monoliths. And what do you think? Is it easy to implement such a pyramid in monolith application? Because, well, the UI, okay, that probably will be our Selenium test. Let's say that we're testing the web application, and so we'll just test as the user test. Unit test, again, all the public service methods will be tested in here. The service, I will say more that in here we will have some integration tests, so something more than unit tests. For instance, there are so-called unit tests with database, the integration ones. But very often we end up with something more like ice cream cone. We have some unit tests, right? But we have a lot of end-to-end tests written with tools like Selenium. And of course, we still test manually with some exploratory tests or with some test cases, whatever. But we test everything with end-to-end tests. Why? Because of the spaghetti code, right? We want to release safely to production, and if we do not know where exactly the bugs may be, and we do not trust the unit tests that much, so we decided, okay, we'll test everything with end-to-end. And how does it look in microservices world? In here, at first glance, it just fits better, right? Because in here we got services, and in here we got service layer, right? So what we do is that we test, again, the front end, the UI test in here. Our service test probably will be testing our services, so it will be tests that will check if the endpoint responds correctly, the status code is correct, response body, and things like this. And of course, unit tests both for front end and both for back end. But in real life, it doesn't look like a pyramid to me. It looks more like a silo, because we still test everything everywhere. Because we still do not trust the integration test and actually unit tests, so we still test everything on end-to-end. So what it means for us, that the QA effort is very big in such an approach, because we need to cover one functionality with tests on all layers. We need to maintain everything. And the advantage that is the best in test pyramid is, for instance, the time, the feedback loops. In here, again, we need to run all the tests again. So something that should be fast is not fast. And actually, we have even more tests to run because we need to run also integration tests. So the time execution is actually bigger. And it brings us to the conclusion that the tests on lower layers are still useless, because we still, again, test everything on the end-to-end layer. And why is that happening, that we fail all the time in most of the cases? I think that there are several reasons for that. First of all is that we do not trust tests on lower layers. And did you ever see a bug report for a defect that was found by unit test? Any of you? And probably you won't see, right? Because unit tests, when they're finding, well, the developers runs the unit test, probably he does it on a local machine. So if something is broken, he fixes that immediately, right? And you don't even know about it. So how you can trust those tests if you don't know if they actually find some issues, right? And once more, we don't know actually what is being tested there. If we want to skip some tests on the end-to-end level or even integration, but how do we know what can we skip? Because we don't even know what is being tested there, what test cases. If maybe some calculations being done here, we don't know that. And of course, sometimes we miss skills, not only the technical ones, because we need to use some other tools. But also we don't know actually what can we test, what test cases can we plan there. And what's more, we do not have support from our dev team. So we have our tests, dev have their tests, and we do not look at each other's tests. We just care about our ones, they care about the unit test, like two opposites. So, but let's think now about a better world where we can cooperate with each other, create some better approach. How the pyramid in such a world may look. So, again, first of all, we'll of course start with unit tests. In here, both for backend and for frontend. In here, we will test, of course, the service methods, some business logic, some calculation in there, things like this. The next layer, and as you can see, I divided the pyramid into two halves. Now we'll talk about the right side of the pyramid, which is responsible for backend. In here, we got component tests. And probably it will be just, again, tests written for our endpoints, but in isolation. So we want to just test our service, not how it communicates with other services, but with component tests and unit tests, we'll have an answer for the question, does our service work correctly? And as you may know, probably that is not enough, right? Because we have lots of services, so we need to test integration here. And I mentioned before the term called backward compatibility. When I once read about microservices, I found the great sentence that is very true for microservices world. Your service may work correctly, but the whole application may not. And in here, integration tests are very useful and helpful. And what does it mean, backward compatibility? Let's say we want to change something in our endpoint. I don't know, maybe we want to add another field which will be returned in a get endpoint. And we want to know if all other services will be still able to consume our response. Or the other way, we got a post endpoint. We want to maybe rename some parameter, right? Again, we want to be sure that other services can communicate with us without any errors. So in here, the contract test may help us. A contract is something like a pact between a consumer and a provider. And we both agree on the contract, what will be returned, and what status code do we expect, what fields, and format of those fields, right? If that field would be a string or an int. And you may think, well, we actually tested it in here, right? Because in here we got the endpoint test, so we verify response body. And of course, we verify the request body in here. So why do we need them? What happens very often is that if we change something in our endpoint as a team, we run the test, and we see that the component tests are failing. So we look at the test, and we say, oh, okay, we changed that in that story, so that's normal, so we need to update the test. And in here, we silently agree to break the contract. So that's why we need another layer. And in here, I recommend mostly consumer-driven contract tests. So in here, we as a team who is responsible for a service will not write those tests. Those tests will be delivered to us by a consumer team. And in here, a tool called Pact may help you. And before going further to the next level, let's go back for a moment to left side of the pyramid, which is responsible for frontend. Many modern applications, web applications are built upon storybooks. In storybooks, we have some small components defined on frontend because in frontend as in backend, we want to reuse stuff, right? So if we have some small form, which is gonna be used in different places of the application, we just create it once, put it into Storyboot, and then we can reuse it in many places in our application, for instance. So in here, we'll test such components with visual regression testing maybe, or of course with functional tests again. The next level, again, are integration tests. And in here, what we can do, we can test our front-end application without backend. So normally, our Selenium tests are in here, but without backend connected. So we mock all responses. Thanks to this, those tests are much faster, are more stable, because we do not rely on backend if it's working or not, because let's say today it was not working properly, so all our tests are red. And thanks to this, we can test only our front-end application. And what do you think? Having only those tests, integration, component, unit, are we safe to go to production? We tested the contracts in here. We tested the front-end. Well, we still need some end-to-end tests. I call it a safety pillow for us, because normally all issues should be found in here. But if we learn how to use the test pyramid, probably we'll skip some tests, because we still don't know what to test there. So that's why we still need to end-to-end layer, where we will check not again all the paths that we tested in here, but we'll focus in on user flows. We'll check maybe one scenario for a user story, or maybe even one scenario per epic in here, not more. And of course, we should not forget about the exploratory tests, because in here, as it was mentioned many times during this conference, there are automated checks, right? They're not testing actually our application, so we still need to test it manually with exploratory techniques to find some issues and ideas for next maybe tests that can be written. And I have some example application with some tests written that I can show you. It's very simple. It consists only of 2 pages. One of them is a list of users, which is very simple. We got a name and a surname, and a button to go to another page, which is add new user form. Again, very simple, only 2 inputs and a button to submit form. And on the backend side, we got only 2 endpoints. One is for getting the list of user, and one is for creating a new user. So now let's have a look. I will start our backend first. Okay, so that's our backend application. We can see that the data model is very simple. We got ID, name, and surname. So, but let's have a look first at the unit test in here. What is being tested? Is the size of the font correct? Can you see it? Good. So in here, what we have tests for the service layer of this backend. So we check if we can add a new user with all valid data. And in a session, we check if method in repository that adds a new user was called. In here, we check adding an invalid user. We check if the proper exception was thrown. In here, we provided a null name. In second test case, we provide a surname, which is null. Then we got validation method in that service. Again, first one is a positive scenario. In second, we add in again with null values. And also there is a test for getting new user. In here we mock a response, what should be returned. And we check if the result is correct. The next layer in our pyramid was a component test, so test that just simply checks our endpoint. I've got them here. They're written with REST-sharp and SpecFlow for defining the scenarios. In here we got feature for creating a new user. We check if we provide valid data, the status code will be 200, and if the created user will be available on list of users. In second one, we got one negative scenario that checks if we will not provide the surname, the status code will be 400. And you may think why I didn't provide it here another scenario for name, which is null or empty. But I don't need to do that because it was already tested with unit tests. So I just want to check only one negative scenario to actually see if the 400 will be returned. And there's a get user in here, a positive one, and also this endpoint allows us to query the results. So there's also another test that queries and checks if all returned users will have the correct surname. So let's run the test. All have passed. And now let's have a look at the front-end side. In here, I do not have a storybook because this application is so small. And when developers try to implement the storybook for here, it looks exactly the same as the application because the component was the form and the list. So in here, I have only integration tests and end-to-end tests. So let's run them one by one. Let's wait. So in here, we'll check the validation. If the name should not be empty, surname should not be empty. If we provide all valid data, then we should be redirected to the list of users. The second one is for users list page. So first test checks the add new user button and validates if we are redirected to a proper page. And then we check if 2 users are being displayed because in here we mock the results. So I know exactly how many users will be there and what to expect. And then we have add user, only one end-to-end test. And as you can see, it checks the user flow. So first we add some user, and then we go to the list of user and validate if the user was there. But there's also a test written with packed. So consumer-driven contract test in here. Our consumer in this case will be our front-end application. So let's have a look at those tests. They starts in here. So in here we got a packed test for get users endpoint. So we first tell the expected body. So we expect that this endpoint will return us a name and a surname, and both of them will be strings. And the body, in here we got an each like matcher. So it tells us that this will be a list of users, not only a one user. Then what we do, we describe how we use that endpoint. So we'll call it with get method to this path with such headers. And we expect that the status code will be 200, headers will be like this, and the body will match the expected one. And what's next? We need to test in here on consumer side if we are using that endpoint in the same way as we declared it, right? Because we wrote the test, but we also need to be sure that we use it in such a way, in the same way, right? So in here is the test for that. And then is another pack described for creating a new user. So again, we describe our interaction and what we expect. And if we run it, we will get a JSON file, which I have it opened in here. As you can see, it's a JSON file. We can provide a consumer name and a provider name, which is more descriptive. In here is just a demo session, so we got only my consumer, my provider. And in here we got all interactions described. As you can see, there is a get and another get that checks probably the queries and a post. And how we run those tests? We just need to call packed verifier, provide the URL of our service, which is up and running right now on the local machine, and provide the path to our JSON file. And as you can see, 2 interactions were checked in here, and both have passed. So now I will stop our service for a moment and change the bench. Okay. Start it again. Because in here, we introduced some breaking change to our model. We have added a new field, birth date, both to user DTO and also to new user DTO in here. So, what do you think about those tests? Which tests will fail? Any guesses? So maybe let's try to run them. Let's try first with the integration ones. Both have passed. User list. All green again. So that's why we need another test as well. But because in here we just check the front end with mocked backend. So we actually don't know if something was changed there, right? So we still expect that there's only a name and a surname. So we got an end-to-end test in here, which actually is failing in here because we call the real backend. So we know that this is failing. But we also do have some other tests, right, on the right side of the pyramid. So let's check them. First, let's have a look at the API test. So we can see that one of our tests is red, the one responsible for creating a new user, because the response code is 400. And what in most of the cases we will do is that we'll change that test to pass the birthday again. So we'll agree to break the contract. And so let's run our pack test to see if they will find it as well. And as you can see that there is one failure that was checking the pact between my consumer and my provider. And we see that we are testing the post endpoint, expected that 200 status code will be returned, and we got 400. So our tests have found the issue. So that was a quick demo. I hope that it gave you an overview of how Pyramid may work in your projects. And in summary, I have some few tips for you. And first of all, architecture really matters. If you plan your test, not only the automated test, but also the manual test, first have a look at the architecture of your system. Because it might be, well, very simple in monoliths, let's say, but very often we get a monolith and next to it a few services, and maybe there's also one front-end application. So let's have a look how it works, what connects with what, because it may help us to plan tests better. And don't be so strict about the shape of the pyramid, because it's just a shape. And in most of the cases, probably you will first have ice cream cone. Then probably you will start test on lower layers, so you will end up with a silo. And when you will still, and after a while, you will see that those tests on lower layers actually are finding issues and are good with it. So you will feel safe to actually remove some end-to-end tests, and you will do that. So in the end, probably you will have an test pyramid. But in the front-end applications, there are also shapes called testing trophy, because in front-end applications, they're not testing a lot of with unit tests. They focus mostly on integration tests. And there is a nice practice which will help you, is that if you find some issue, first try to reproduce it with unit tests. If it's not possible, then with some component tests. And again, if that's still not the level, then integration one. Thanks to this, you will learn actually what you can test there, what bugs you can find there. And the most important one, this is a whole team approach to QA, because you cannot achieve the test pyramid on your own as a tester, because it's a whole team responsibility. You need to have developers involved to that, because you will not write all the tests on all layers. The front-end ones, those will be probably written by front-end developers. The back-end one, probably with the back-end developers too, but you can help them, because it takes the whole team to build the pyramid. Thanks for listening. That was everything.
Any questions? I will have one, if I may ask. You told, from your perspective, yes, from your practice, how much time do we need to spend to change this ice cream cone
To pyramid?
Yes. It depends, of course, on project, but based on your perspective, yes, on your practice.
You need to change the mindset of your team, and it takes
I
time.
thought
It takes a lot of time. I am working currently with one team, and we're almost there, and I'm working with them for about 3 or 4 months so far.
So half a year, let's say, we can manage.
Well, it also depends on the project, because if you start a new project, a
It's easier.
greenfield, yes, then it's very easy to start with the pyramid.
Yeah.
But the hardest part, if you got some project which is in maintenance phase, or you're doing some architecture, things like this, and you already got some end-to-end tests, and then you need to change to the pyramid. This is not easy, because you saw the end-to-end tests that are good, that they're finding issues for you. You know that they're not fast, but you can live with it, right? Yeah. So you need to, at some point, delete some of them, right? For the sake of the lower ones. And that's the hardest part again.
Okay. So, thank you. Any other?
Hi, Natalia. Thank you for your talk. I have a question, because the foundation of the pyramid are the developers and the unit tests.
Mm-hmm.
How you gain how do you gain the trust into the unit tests? What do you do to build that trust that is the foundation for the pyramid?
Okay. First of all, I ask developers to add testers to the code review. If they're writing some unit tests, I ask them, please add testers there, because they will first see actually what is being tested there. That's one point. Second point is talking with each other. If developers are running the test and see, okay, this one is failing, they can communicate to testers. And thanks to this, we'll all start trust them more.
Any other questions? No? So thank you, Natalia, for your presentation. Stay with us.